Hello ladies and gentlemen, today we are going to be improving rendering in my game engine. So there is quite a bit of code duplication currently, and I don't like that. I want to make the code duplication as less as possible, so I can manage this huge game engine on my own. It's quite ambitious project, and I have to be able to manage it on my own because I have no other developer. So the problem is, we have three different renderers. They are not really that different from each other, but they do different things. They have different configurations. That's the biggest part of this. So there is a shape renderer. This renders shapes like rectangles, rectangle lines, and etc. And then we have a texture renderer. Texture renderer renders a texture. Just one texture, by the way, not multiple textures. That's a different thing. You have to create more than one texture renderer to be able to render more than one texture. At least currently it's like that. In the future it's not going to be like this, but that's not important right now. This also draws rectangles. Right. It draws rectangles, but with a texture on. So we have a bitmap font renderer. This also renders a rectangle. Rectangle with a different texture. It's actually a texture renderer, but it has a different format. This one is quite unique actually. I'm not sure if I will be able to make this one generic. But because this thing has a code point, stuff like that, and you have to be able to extract a code point and do stuff like that, it won't be, I'm not sure how to do that in generic form. Because this thing is already generic. As you can see by this. It's already generic, but it's not enough here. Okay. So what I want to be able to do is say, okay, create renderer, or maybe something like put, which is the namespace of my engine, and say render and do like a shape and do something like this. This is the shape render. This is the shape renderer. Right. Well, it's supposed to be like something like this probably. Or this might be a crate or something like that. And this is going to be something more or less like this. Currently, this is how it is actually. The only difference is this is the renderers are in a different namespace, but currently it's something like this. But the problem is they are duplicating so much of the same code that it's kind of frustrating to work with and it's error prone to work with. So I want to do something like renderer. I want to make this a renderer like this, create and dot shape, something like this. I want to turn that into this, right? Okay, so let's try to do that. Let's try to do that. Let's create a new folder first of all. Okay, source render. Maybe we don't need a new folder. Maybe I can just call this renderer. I think I'm just gonna call this a new renderer, just renderer, yeah. source render.z. Right, save this. Let's get the license first, so we have no problem later. Yeah. Right. And I'm going to add this to the namespace here. Import this render.z. Okay. So we are going to have modes, and I want the modes to be kind of compile time modes. Although that still duplicates the code, and it just does it in compile time without me explicitly saying that, okay, duplicate this code. But maybe we should make this. Maybe we shouldn't make this compile time, because if I make this compile time, the code is still going to be duplicated. It's just not going to be by me. It's going to be by the compiler, which will result in bigger binaries. That's a thing to keep in mind with compile time stuff. Because we may have so many different configurations of the same renderer, like a shape renderer, but okay, you can render this in a different way, like add something to it later on, and maybe we're going to have hundreds of shape renderers, and it's going to duplicate it like 100 times, maybe. Probably not going to duplicate the 100 times, but still, it's still a problem, I think. So we're going to be doing it in a more runtime way. Let's see. Okay. Let's have mode. And not sure if I should call this a mode or capability. I think I want to call this a capability, because this way a shape renderer can have a texture as well. So you can kind of combine a shape rendering and a texture rendering, and this way you can have both of them. I think that's kinda okay. Let's make this in enum. No, it's not an enum, it's a struct actually. Okay. Yeah. So the capability, shape, it's a boolean, of course. And the texture is a boolean. And a bitmap font. Bitmap font is still a kind of hard to do. I'm not sure how to fit that into here. I will think about that later on, because it's kind of, I have a tool that generates a bitmap from a font, from a TTF file, and it generates an atlas given the code points, and then the bitmap font renderer renders them in a way that in the way that atlas was generated. The atlas, I think show you an example of the generated thing in there. Okay, I can't show you because there isn't one currently. I can show you here. Monogram. Yeah, it's kind of like this. So we have a size, the entire atlas size in pixels, font size, and the glyph information and the glyphs like this. And there's also the generated image, at least that's in the PAM format, PAM. This is the command line that was generated with, as you can see. It's kind of like that, and to render that, you need to kind of inspect this, kind of get this information somewhere. But it's kind of difficult to do. You have to give quite a bit of information. Right. Anyway, let's continue. So we're going to have a create function, right? This is going to return itself, by the way. Let's have const self. No, not import. It's this. Okay. And I'm also going to import put here. Right. Okay. Let's have a separator here. What the fuck? Okay. There you go. So this is the create, and this is the destroy. I always put this kind of stuff in here, in destroy or drain it, in my data structures, or just structures that trace themselves and initialize themselves. Because when after destroying, when you make the thing undefined, the variable undefined, you can easily distinguish in debugger that, okay, this thing was destroyed, and why am I using it later after it's destroyed? So it kind of gets, it's a way to help with the use after freeze, basically. This is not a free because we're not allocating it, but this is more of a use after destroy in this case, I guess. But it's the same concept. So we're going to have a capability here. Capability. And this is going, I think I'm going to give them default values here. Normally you shouldn't give default values because default values makes it easy to misuse the structure fields. For example, if this shape field, or let's just say shape ID, for example, I don't know. So if I give everything a default value here like this, and if I modify shape ID when creating it, say, okay, this is 20, but I don't make this shape true because no one warned me about it. The compiler didn't warn me about it because it's default initialized. I may think, okay, what the fuck is going on? Why is my shapes not rendering, right? You may forget this. I did this a lot. I actually shot my foot with this kind of features, the default initialization before, in this engine as well. I called out what I just said. So it's kind of important to know when to put default values in a struct and when to not put them. Okay, so this is the capability. We're going to be using the drawer struct here. This drawer struct is basically a vertex drawer. This is actually the generic renderer, but it's not render dependent. It's just a vertex drawer based. It just draws vertices. If you want indices as well, it draws them as well. It puts them in a struct basically with vertices and indices. Then you can just give that into any kind of renderer engine. It's quite generic. It doesn't really render it by itself. But it also does batching. Not fully automatic batching. You have to do some of the stuff by yourself, but it does batching. This is the batching thing. And we need to create alias for it. This is the drawer we're going to be using. Put drawer and okay, what happened? Okay, vertex type. Right, this is one of the problems with this. It has to have a vertex type. We need to give it a vertex type. But the texture vertex and the shape vertex different from each other. They're not they're not really matching. So to do this, I think we're going to have two different drawers basically. But this kind of path leads me down to making them separate. This is why I made them separate in the first place. Because the drawer is different, the vertex type is different, everything about them is different, except the code itself. That is, the configuration is different, but the code they are using is basically the same code. There is nothing different about the code itself. Right. So I guess we're just gonna see, because I didn't really plan this. I'm just going along as I write this out and film it. So I guess we'll see. Texture drawer and a shape drawer. And drawer. So this is going to be shape vertex. And we can just call it vertex shape. I'm trying to get used to the putting the drawer first. Drawer shape, not shape drawer. Because it makes it quite easy to uh, use grep, like use grep and stuff like that. It makes it easy with autocomplete as well. And this is drawer texture, right? So we're going to define the vertex as well, vertex shape. So how does it look like in shape render? Shape, no, shape renderer, please. Okay. So vertex looks like this in shape renderer. You're just gonna copy that. Vertex shape. Right. Okay. So how does it look like in texture then? So as you can see, there's only one additional field here, which is text coordination, text coordinates. Because the if you take a look at the GLSL file, generic texture fragment, not the fragment, I guess it's the vertex one. Yeah, it takes in the texture coordinates and gives that to the fragment one. Then the in the fragment shader we use the texture thing here with the sampler and we multiply the colors. So that's basic texture rendering in GLSL. So there's also okay, so there's an interesting thing in shape renderer. I just import the drawer directly, so maybe that's a better way of doing it instead of depending the entirety of code. Yeah, that makes more sense to me actually. Let's go like this: import drawer. That's it. Just depending on one file is better than more than one, I guess. This is the drawer. Okay. And vertex shape. Okay, I didn't copy the vertex texture apparently. There you go. So these are the types we have. And then we are also going to make them in this indexed. Yeah. Okay, so that should give us that. Right. For fields, so my engine, if you don't know, my engine is separated into two parts. The most important part of my engine is the Karga part. Karga is the core of the entire engine, and it is separated from CUT. CUT depends on Karga, but it doesn't integrate with it. It just depends on it. It's kind of it's like a different library on top of Karga. It's not inside of Karga. That's the difference between them, and that makes it easy to separate the modules, and it's easier to make modular engine with like something like this architecture. The interesting part is that my graphics renderer, my graphics interface is quite different. One may expect. The entire thing depends on configurations. You say the intent, you give a configuration to the renderer, and the implementation just figures it out somehow, right? It's kind of hidden from you. The implementation is entirely hidden from you, so you don't have to worry about it. And we have to create a surface. Well, no, the surface is going to be given to us. Pardon. We are going to be creating shaders and materials and renderables. Now, we're going to be creating 4 shaders. So 2 for vertex, 2 for the vertex shader, 2 for the fragment shader. And one of them is going to be for texture, one of them is going to be for shape. And we're going to be creating 2 materials. Materials, what binds the surface and the shaders together, it makes them one, and then you can use it. And you can update the shader uniforms and stuff like that. The material is going to be two. We're going to create a 2 material. One of them is for the shape, one of them is for texture again. And renderables are basically sprites, kind of sprites, not entirely. You have a lot of configuration options here. You choose the surface, you choose the material, you choose the drawing order, you choose the viewport, the blending mode, drawing mode, and drawing shape. And all of these can be static or dynamic, which basically means, okay, you can update this and you cannot update this after you created the renderable, which allows the implementations to be more efficient with their data. That's the whole point of them. Okay, so we know what to create. So we have to have, by this logic, we're going to have a vertex, or we can just call the shape shaders. We're going to have 2, right? We're going to depend on Karga, by the way. So that's that. We're going to depend on Karga, not CUT. That's a different thing. They are different. They're separate. And Karga graphics shader ID. We're going to have 2 shaders for this. we can actually make this a struct and call it vertex and fragment, so we don't have to rely on code comments to know which one is which, I guess. Karga graphics shader ID, and we're going to be doing the same thing for the texture shaders, so we might as well just put this into a named struct, not anonymous one, but a named one. I'm not going to make this public because it doesn't have to be, and I'm just gonna call this vertex fragment. And this makes me realize I already have this kind of thing in the shader, I think. Yeah, I already have this kind of thing here, as you can see, in material. I can probably just copy this actually, because we also have to save the description of the shader, and that's basically where the entry point and stuff like that. It basically tells, okay, what uniform is what is there, what is where, right? I guess you get that. Where is the attributes, where's the uniform buffer, where's the combined image sampler, for example. It tells the render implementation how to use the shader, basically, right? It's very Vulkan-like, so that's kind of a bizarre thing, but that's fine. So we're going to be doing, let's just put an alias in here, right? Vertex fragment, it's in Karga, graphics, material, and vertex fragment. There you go. Vertex fragment, and this is also vertex fragment. So now it's called vertex fragment. I guess we can call it vertex fragment as well. Vertex fragment, and we can remove the shader from there, something like that. Then we're going to be, okay, this is the capability. I'm also, we need to put, let's look at this. So what do we have in here? We have a renderer, we have the interface, the rendering interface. The surface ID, the shader is it Sprint5 or something else. The ordering, viewport, and mode. Mode is how this entire thing is rendered, updated, or reset. I think I'm going to have this because I think this is quite important to have. We're going to be having this capability. I guess we can add this into the capability in one struct, like it's mode. So this is the capability, and I'm not going to put default value for this one though. And this is the capability. We're going to have the renderer interface. I guess that's going to be the first argument here, which is Karga graphics interface. And we are going to be accepting a GPA, an allocator as well. So we need to import std. Okay. Let's make this like that so we can see it easier. And we're going to have I guess this is not really capability. The mode is not really capability, but We can call this like dynamics, maybe. Maybe that makes more sense. Okay, so that's that. We're going to, what else do we have in shape render? We put the MVP here. I guess I'm not gonna put that right now. The viewport is important. The surface ID also important. This thing is also important, right? Um, this is not really transferable at this point though, because in graphics I may put more than one shader type of shader here. I'm going to put the CPU shaders here as well at some point. So it's not really fair to, okay, is it Spirit 5 or something else? Like, okay, that doesn't really make sense much, right? So we may as well put that something. I think we can just get type of this enum and define it here. Okay, I'm not gonna worry about it right now. I'm gonna put this in dynamics, by the way. I think that makes sense. That's going to be in dynamics. What else do we have? The surface ID. The surface ID is not gonna be in dynamics. I think that doesn't make sense. It's going to be in here. The ordering of the renderable. Right, that's kind of important. Okay, so the ordering. We can basically have two information in one field, actually. We can make something like this, and this can be the ordering. Although I'm not quite sure if this is a good idea, because putting two information in one field is kind of compacting it, and it may not be so obvious at first. But we'll see, I guess. We'll see. This is renderable config, and this is the order, right? And this is null by default now. So null means no shape rendering. And this is the same for this. Okay, there you go. And we compacted that information. Okay, viewport. Now we can give viewport, we can give two different viewports for texture, for shape, but I don't think that's really that useful. The ordering is useful, but viewport, two different viewports in one renderable or in one rendering abstraction is kind of pain in the ass, I think. So I think I'm not going to have that in dynamics. I think I'm going to just put that in here, like this, viewport. Or maybe we can put it in dynamics, but I don't want crowd. I don't want to make a crowded function call. I want to, if I can, I want to separate them into a struct and just pass the struct. But I'm not sure what to put in dynamics and what to put in the arguments in struct. It's kind of difficult to tell, at least for me. So So I guess I guess I'm going to put stuff in dynamics where I can change it later on. If I don't want to change it if I can't change it later on, I don't want to put it there. I think that makes sense. So this thing should be in here. And this thing should be in here because we can change this later. Mode. I think I also want to be able to change this later on. So that's different. That's a good distinction, I think. These are the things that can be changed later on. Later, change after creation. I think that makes sense. Great. Right. So what else do we have in shape render? The MVP. Do I don't have to provide this. I'm not going to provide it right now. Right. So that's that. So the error set is going to be huge, by the way. Create error. Error set is going to be huge. What did I put in shape render as the error set? Yeah. Material. We're not going to have that. Okay. That's the create error. And vertex fragment shape, texture, and so what else do we have? Okay, we have material, renderable. These are the renderable configs. Oh, so we're not going to have. Oh, okay. I think I kind of confused the two. Okay, but we can have this, right? Yeah, I think we can have it. Like, yeah. Okay, what I confused was the. I thought we were going to have to store this information, the shader description. But no, we're going to actually store the renderable configuration, not the description itself. But anyways, I think it's fine. Oh, I think actually in this case we are going to be storing that information because we may later on decide to not have shape rendering anymore. So get rid of it late as runtime as well. So and maybe we're going to have shape rendering. So we're going to we're going to have shape rendering after the creation of this renderer. So yeah, I think that okay. Now it makes more sense. It didn't make sense before. Now it makes sense. Okay. So we have renderables and material. So let's have a material here, and this is going to be shape material, Karga graphics material, and we're going to have the texture as well. And we have the configuration of the renderables. Right, that's important. And so I guess this is going to be a struct here. We're going to call this. I guess we're just gonna call. I don't want to make it. I guess we can call it sprite. I don't. really like that actually, but I guess it's fine. I don't want to call it renderable because renderable is already taken by the code by the Karga engine. So I don't want to confuse myself later on and reviewing this code like 6 months after. Why did I call this renderable? You know. Um, so I'm gonna call this sprite, even though it doesn't. It's not really a sprite, but it's fine. So it's going to have the config, which is Karga graphics renderable config, and it's going to have the renderable. This is one of the reasons why I didn't want to call it like it wouldn't it like if I make this renderable. Okay, so okay, we have a config, fine. We have a renderable. Like, should I just call this ID? But that also is kind of yeah, I mean, I guess it would be kind of fine, but I don't want to do it anyway. Renderable ID. This is that. So we're going to have sprite shape sprite. Oh no, it's not Karga graphics, it's just sprite. And sprite texture as well. What else do we have? We have a batching part and batch GPA. And we have a mode in here as well. So batching part is, I think, batching. We can put this in sprite, but I think I'm gonna call shape batch shape and batch texture. I think I'm gonna separate them like this. Just the struct itself, not the actual code. I think the actual functions that does the batching is going to be generic. I think I can manage to do that. It's going to be that, and it's going to be that. We're not going to. Shouldn't we, like, it doesn't make sense to have lines in a texture rendering, like, right? Does it make sense? I don't think it does. So we're going to be removing that. So let's remove this batch thingy. And what is this vir? Right, vir is inside of the drawer. So this is drawer shape. That's vir. And this is the drawer texture. That's vir. Vir is as abbreviation for vertex indexed renderable. Which makes it easy to make batching. Even though it's like 10 lines, it makes it easy. Trust me on that one. You'll see later on. So, this is the sprite shape, this is the sprite texture, and do we have enough? Do we have everything now? We don't have the mode. We don't have the mode. And we don't have the viewport. I think I can just say the dynamics like this. I think that's fine. Right, so now let's get to the creation. I'm gonna put this first, by the way. And dynamics is going to be dynamics. Okay. So GPA, this GPA is going to be batch allocator. Let's make it kind of explicit in there. And This is just going to be in here. Batch allocator. I'm gonna put it like this. Batch allocator. And this is batch allocator, just the same thing, right? We're not going to be storing the renderer. Renderer is going to be passed in as a function parameter always, because you need to know which function actually takes in a renderer and actually doesn't have to take a renderer. Because renderer functions, the interface functions in here, these are heavy functions. These do a lot of things. And currently, my rendering interface is not multi-threaded. It's not suitable for it as well. I will take upon that challenge later on. I have few ideas how to do this, but currently this is single-threaded. So it's going to block, and it's going to block a lot if you if you just update your MVP, for example, in the shader, well, it's going to block. That's not good. That's slow. We have to be careful of that. So the shaders. We have to create the shaders. So shaders are something like this. I'm just gonna copy paste these things in here to renderer. Okay, I'm gonna do something like this. Source renderer. Put this in there. Add this and put this in here as well. So these are the vertex shaders. I'm gonna call the shader vertex shader and shader shape. Something like this. And these are the shape one. These are for the texture. There you go. Maximum submit count. I think I'm going to make that in put that in dynamics here. Well, maybe not. We don't really have to, right? It doesn't really affect too much. So maximum. Okay, we'll get there. We'll get there. Don't think what's not important right now. Okay. Right. So the shape, I want to create a function where we do create the shaders. So this is going to be vertex fragment shape. I'm gonna call this I'm gonna make it like this, even though I don't like the naming. I guess it's going to be fine. So this is going to take self as mutable, and it's going to have the shader creator. And by the way, this doesn't have to be this can be generic, right? So we can just say, okay, this is the now this is going to be code duplication, but it's a compile time code duplication, not by hand. So even though I said that will still increase the binary size, this is small enough that makes sense to use it, I think. Using generics compile time code generation for the entirety of this renderer would be a bad idea though. So this is going to have I'm just gonna use the trick where okay, I'm just gonna use the call this field. So this is going to be a compile time string. So right, it's going to be whoa. You're gonna see what I'm going to do right now. So this is the vertex fragment. It's going to be a pointer field. Right. So left hand side. So this is self field. Um I'm gonna call this name and make it something like vertex fragment. Make it even more cursed actually, and stuff like this. Cursed, I know, but it works. Trust me. So what do we have in here? We have an ID and description. Okay, I'm going to, by the way, make this. I don't want to use the alias anymore. Okay. The reason why is I lost the information where this struct came from. I don't want to lose that information. Right. So this is the vertex fragment. Right. I'm also going to be using another compile time curse stuff in here. You'll see. It's going to be crazy. Disgusting, I know, but we'll see. So I'm just gonna copy paste the creation here because it's not that important, I think. Okay, this is the entire thing. And this is the should shader be specified boolean. Okay, vertex shader source, right. We're going to be doing fields. This is self. This might be a decal here. Do we have decal? We don't have decal, right? So this is going to be, we're going to be copying this. Source plus name, and that is the source. This is the GL plus GL. I think you get what I'm doing right now. And this is the vertex. Right. Crazy, I know. But this is the vertex, which is field, self, vertex. Ladies and gentlemen, this is why you use this kind of stuff. This is not gonna work. Hold on. It's not gonna work for vertex. Yeah, I'm just gonna make a basic thing here. Vertex shape. It's going to be in compile time. It's going to slow it a bit, but it still should be fine. It's going to slow the compile times. That's what I'm worried about, doing this kind of stuff, but okay. So let's make it like this, so it's a bit easier to read. There you go. So that's the vertex. And this thing has to have a renderer in there, so let's put that. Karga graphics interface. Right. That's the renderer. So we have to do the same thing for the fragment shader. This is just vertex fragment. Vertex fragment. Oh, the vertex fragment is the okay. So these are the vertex is going to be changed to a fragment. Right. And that's the fragment. The vertex shader. The fragment shader. Okay, I think that worked out fine. And the only thing we need to add in here is the texture coordinates. And this is not going to be, this is one of the things that's going to be using this kind of stuff. Unfortunately, I think. And okay, how can I do that actually? I can't have an invalid, I can't have an invalid thing in here, so I don't want to duplicate the entire thing. So we can do vertex shader layout, and we can do something like this. Description. So this is this kind of stuff. And copy this in here. The order is not important, by the way, in layouts. It doesn't matter. At least it shouldn't. I didn't really test this actually. I didn't actually test that, but it shouldn't matter. I guess let's test it. Let's see if it matters. We will test it now. Okay. So this is the thing. Right. So this is going to be if we're going to be copying this thing in there. If this is shape, it's going to be nothing. So if this is this, then do that. In the otherwise, we're not gonna do that. Can I just put this as void? I'm not sure if this is gonna compile. We're going to have to make a test case, but this is going to be texture renderer. How did I do that in texture renderer? This is the attribute. Okay, let's just copy this, paste this. Okay, so it's kind of we need to copy, put this in here. I think this is not okay. So can I just do dots here, can it infer that? I think it can infer it. Okay, great. So this is the vertex shader, this is the fragment shader. So we can do now vertex fragment. And this is the vertex shader. And this is going to be vertex shader. In fact, I'm just gonna make this something like this, and vertex shader, vertex shader, fragment shader, fragment shader. Okay, let's get in here. What is the name? Okay, so this is the thing we need to put in there. Vertex ID. These are called ID and descriptions. Okay. Okay, so it's going to be vertex shader description. This is called create. I'm gonna make this DSC. So it's kind of the same thing as the field name. And this is the fragment shader description. Okay. Put this in here like that and put that there. So it's a bit. So I'm going to put an air differ here. So we make sure clean up the shader. And we can do vertex shader destroy. And this is the renderer. And this does return a boolean. We don't care about the boolean. We can assert this to be true, but it's fine. Fragment shader. Okay. So that's that. And I'm gonna call. So this is going to be vertex fragment shape. It's going to be just try. Oh, we can't put self in there, right? Yeah, we can't put self in there. Okay, we have to use something else then. We're gonna do something like this. Even though it pains me to do something like that. Okay, there you go. And we're going to return the self, right? Self dot vertex fragment shape is going to be try self dot. Maybe we should put it like this. So create vertex fragment. Right. It's going to take the renderer. It's going to take the should shader spirit 5, and then it's going to take the field name. And you can just replace the shape as with texture in here. And we can put an error differ here. Let's put that as well. This is something I didn't do in the other ones, even though I should have. So vertex shape. Oh god, oh boy, this is going to be a pain in the ass actually. Vertex shape vertex shader ID destroy. Okay. Vertex well, okay, I'm just gonna change it myself. This is fragment shader. These do return booleans. So we do this different thing in here. And so these are the fragments. Okay, so that's that. I want to make an example. New render. I want to make a test case. So what is the easiest way I can copy paste something in examples? Which one is the easiest? None of them are the easy actually. I'm just gonna okay, I'm gonna try to copy paste this entire thing. Debug allocator thread. Oh my god, okay. The log panic is important. Put that there. We don't need most of these things. We don't need the audio. Basic rendering. Let's just call this basic rendering. Okay, that's that. We don't need any fixed delta time things in here. Remove these things. Okay, we don't need this. Android pause, that's important. These are not important. Okay, that's important. That's can be removed. That can be removed. This can be removed. And audio thing can be removed. Fixed delta time. Maybe we don't need it actually. Let's make it. Let's just have it. This is F32 by the way, not U32. Fixed delta time can stay. Background color. We don't need this one. We don't need this. We don't need this. MVP. These can. I will be using this, but not right now. So the G state. Audio data can be removed. Don't have this kind of stuff. We don't have this kind of stuff. I'm gonna make this just running. Void. Okay. Don't have that. Okay. Draw calls. Remove all of it. We don't have this. And we also remove this kind of stuff. Okay. So that's, I think that's a basic, what did I call this? New render. Example, new renderer. Okay. We are in renderer. Okay. So there's things in here that's not used. Surface ID. For now, let's copy. Let's ignore this. See if it's gonna compile the examples. Okay. It should compile. I didn't make any mistakes in the syntax, and I didn't, but new 91. Oh, this thing. Okay. If it is running, if it's Android pause, well, we don't really care actually, do we? No, we don't really care. Right, we don't care. We don't really need Android pause. Okay. That's not important. We can just recreate. We can just destroy everything. This, I don't need to have this, by the way, because otherwise we won't be able to say, okay, this is just running though. Okay. The Android pause stuff in here basically needed for when you, in Android, you can put the application into background, right? So, but it doesn't, the Android doesn't destroy the application itself. It just pauses it. It pauses the execution. So if you want to be able to recover from that, you should not destroy the entire engine. You shouldn't deinitialize the entire engine. You should just wait. You should just just wait until it's created again. Until the Android tells you, okay, you can, I'm starting to continue the execution. Android tells you that, and then you can do, you can just continue where you left. That's why I do the Android pause here. That's why it's needed. Although we're not going to be doing Android development in this video today, but it's nice to have it. It's just 2 lines of code anyway. So okay, so we got this. Okay, and apparently I didn't destroy something. Is it the present? This shouldn't be actually. We did destroy this, right? This is quit. Destroyed window. The surface wasn't destroyed before. It's currently in use. Okay, I think real quick. Real quick. Okay, I see the error. I see the error. Hold on. Okay, this is the thing I need to put in there. By the way, I should have that in. So this is the right. Okay, real bug fixing, quick bug fixing, I guess. So this is going to be in here, and shader destroy, surface destroy. I put this in here. Okay. Okay. That should fix it, I think. If it doesn't, I'm not sure. Wait, what the fuck? Oh, I didn't put catch. Okay. Uh, I also missed that in here. Okay. My mistake, broski. By the way, look at this freeze. Oh my god. Oh, horrible. I know. Okay. There you go. One bug fix later. So where did I left off? Okay. So we were doing the renderer, right? Yeah, we were doing the renderer. So let's create this in the new renderer, right? Let's create it. Var renderer. Put renderer. and this is undefined for now. We're going to be creating the renderer in here. Renderer creates. So this is going to be put renderer, something like that. It's going to be have errors, and if we cannot really recover from these errors, so I'm gonna log panic this. Create renderer error is this thing. So that's that. So it's going to take in. Okay, what the fuck happened, bro? Okay. Why is my autocomplete not working? Okay, so I know that it's going to take a GPA, so we give GPA. So it's going to take the renderer, and let's see what the this thing tells us. Okay, so I'm gonna make this into watch incremental, even though incremental doesn't really work on Windows, but it's fine. So it's going to okay, so we didn't give enough arguments. So surface ID should shader. Okay, the surface ID surface and should shader be that thing. Do I have something for that? Why is my LSP not working, by the way? And also this is basic running. LSP, please work. Okay, LSP not working. So this is S-Carga, right? I don't have. Okay, apparently I don't have that. Okay, that's fine. It is going to be a true, but this is a switch case on audio code cargo graphics target. It's a switch case on this. So dummy is false. Dummy and the dummy is a compiler, by the way. This is a to do. Vulkan true. OpenGL false.
A few moments later.
Okay, I was creating the renderer, right? So I was creating the render. Let's start. Let's create the dynamics. So let's see what's the compiler gonna tell us. Okay, it's missing the viewport. Great. We can give the viewport like this. I don't know what this is doing, by the way. If it is Android, it's getting the minimum. Oh, okay. Ah. Well, I guess that's fine. Okay, we can do that. So the viewport is going to be static. And let's make it something like this. So the position of it is going to be 0, 0. And the size is window size. Okay, so what else? Mode. Mode. I'm going to make it immediate. Immediate. And it's telling me, okay, it's telling me it's an invalid field name. Apparently I gave something wrong in here, even though this is the intended use in there. If it is shape, vertex shape. If it's texture, it is vertex texture. Invalid field name. Okay. Shape texture So found void. Because this thing is returning void, right? That shouldn't be like this. It should be like this. It's still giving me invalid field name though. So that's bizarre, actually. Okay, what is the name? It is texture and shape. Right. Shape, texture. I wonder why this is... I don't have to force this to be compile time because it is already compile time. Oh, I have to force it. That's bizarre because it should have been compile time anyways, I think. Source has no member named hashtag. Okay. Um, these things has to be compile time, by the way. Are these compile times? They are apparently compile time. So it's warning, it's giving me an error. Root source file struct render has no member named hashtag. Okay. Compile log. So what does this give me? Ah, because this thing has to be... Right, I'm so dumb. Okay. This is name plus file source. Okay, so it's something like this. Okay, that was dumb. Okay. It's supposed to be like this. So let's copy paste this. Source gen. And this is the fragment. As vertex fragment. There you go. No field name attributes in here. Because this is a layout. And this is also a layout. It expected that. It found void. Okay. So, can I just not put something there? Can I put the if here? As this. Okay, here's the thing. I can't put invalid thing in there. Maybe I can. I'm not sure actually. Can I put the if statement over here? I don't think I can, by the way. Yeah. Okay, I think this should be fine. If I just put... This might bite me in the ass, but we'll see. Okay, we'll see. So it expected type that found GPU. Ah. So we cannot use this thing that easily. Okay. So we're not going to be using that. We're just going to be using our own vertex fragment. Okay, that's fine. So it's going to have vertex shader. I'm just going to call it shader without the ID. And this is the create. Let's call it like that. And vertex shader. This is going to be Carga graphics shader. And this is the fragment. And this is the create dot GPU. And this is the fragment. There you go. And create. Okay, there you go. So what's the error? Okay. 48. These are not IDs. And I think I can put this in the does shader not have destroy? Ah, this is supposed to be not shader, but shader ID. Fragment shade. This is shader. Okay. Okay, it's compiling. So I'm going to put this destruction in here. Pub fn. It's not. It doesn't have to be pub. Fn destroy. South is going to take itself. Vertex fragment void, and it's going to return. It's also going to take the renderer. So it's going to be cargo graphics interface. Pointer to that, and we can just copy this string in there and put that there like that. And now we don't have to do this kind of stuff. Defer vertex fragment shape destroy. And this is the texture. So that's that. That we can do, I think. And it does take render, so there you go. Okay, great. And we can make this own thing. We can just do vertex fragments, and we can call this vertex, or we can just say don't do that. Do vertex fragments, or we can do just do a return here, something like this, and pull this function into this struct here, so it has a member like this, member function like this. And yeah, that seems a bit better in my eyes. So this is going to be, now we can actually do something like this. Well, kinda, at least. I don't think everything is going to be fit in there. I also want to make this nullable, because if you remember, we may not have the shape rendering available in the dynamics. So I'm going to put actually a default values in here. Maybe not actually. Let's just put them in here so the user is incentivized to use the create function and not just do their own thing. Okay. So that's that, and material shape, and these things are also like this. Sprite shape. These are all nullables, I think. Oh well, maybe not the I think the create can be I guess it's fine. I mean, I guess it is fine. It's not fine. Let's say create from scratch. Or let's do something like, okay, the IDs can be null. And it still creates a problem, but I'm gonna put them undefined for now. It's kind of a difficult thing to do. And these things can be just null, right? And I think sprite. What if thing change? Can it change? Yeah, it can change. So I think these are also going to be nullables. I'm not going to implement everything right now. I'm just going to implement the basics so it can render a shape and a texture. That's what I'm going to implement in this video today. Because implementing everything is going to be quite a lot. So at runtime, okay, you want to draw shapes now, so we need to make sure that the shape is created, the configuration is correct, and stuff like that is going to be too much, I think, for this video. Even this is too much, but I need to put this into Flutter Dynamics shape and put this in here. And this error defer is in the scope of this, so that's not great either, by the way. So so this has to be something like this. Well, maybe not. It does actually. So you see the kind of problems with RDFR. If I put this in here without this thing, right? This RDFR is only valid in this scope, not the entire function. But if I put it here, and this thing fails, and we don't have shape in the dynamics, this is going to create a problem. Well, actually it won't, because it would have created a problem, but actually it won't, because we are taking advantage of It's still kind of undefined behavior, but we kind of take advantage of the property where I specifically designed the render graphics interface as destroy functions cannot fail. They may not destroy anything, but they cannot fail. So they can return, okay, I didn't destroy anything, so it returns false, right? So, but we don't check that in here. We don't care, right? So it's gonna still continue execution as if it has been destroyed. But the undefined part of this is kind of iffy. It's iffy. If I didn't have that, if I didn't design my interface like that, if I didn't design the destroy functions always successful, I would have it. I would put this in here because I'm going to put other stuff in here, and I would have to put this in here as well because this thing can also fail, right? So it's kind of pain in the ass, I guess. Let's just say that. Is it better than C? Yes, definitely. In C, you would have to use goto, and that's going to be... well, we can just put an error defer at the start, I guess. We can just do it this way. Yes, let's do it this way. In C, you would do kind of similar things to this kind of error defer here. Although I don't like it. But it is what it is, and it is what it isn't, I guess. Okay. This is not self, by the way. This is self dot vertex fragment shape. And yeah, something like this. Text fragments texture. Right, and this is dots, okay. And so now we need to be creating the material ID, by the way. Right, material shape. Material shape, it is null by default. And material texture is also null by default. So how do we create the material? The interesting thing is material creation is actually very easy. You just give the you just give what you already have, basically. So this is self material shape. Maybe I should put this in a function as well, but it's so inconsequential that I don't think it is worth it. I can just duplicate this, I think. That's what I'm thinking, at least. You see what is this? I mean, look. It's that simple. Do you really have to do that kind of stuff? You know? Yeah, so this thing is going to be, by the way, a whole thing in here. So we also need to destroy the material. Well, if you have it anyway. M.destroy render. And this thing can also return a boolean. Yeah. And I think this thing does take that, but oh, it doesn't take that. Okay. Material, texture. Okay, there you go. So now we need to copy this thing in here. So this is the code duplication where it is a bit frustrating to do. Yeah, right. The shape, okay. That's why I can make this generic, but is it worth it? Is it worth it to make this generic? Like, I don't think so. It's just 2-3 lines of code, you know? I mean, it's like 8 lines or something. But I think this kind of way of doing it is simple enough. It's simple enough. So that's the air defer, and we are missing the sprite shape, right? Yeah. So sprite shape. So sprites are a bit different. They are quite more interesting than the shape and the material and the shaders, because we need to create a renderable and a configuration. By the way, I need to put this row in here. This is going to take renderer. Right. Okay. Okay. So the renderable creation is dependent, so I'm gonna make it like this. It's dependent on the batch shape and the batch texture, right? So shape renderer. So these are the configurations, and the configurations. Okay. Since we don't have we need to have a well, we can just put that in here, I think. fn create shape. We need to give 2 configs for shape. Well, wait. Doesn't this make more sense to put the config in here? Because triangle config and okay, hold on. And the line config. I think this makes more sense in a way. And this sprite doesn't have to be a sprite now. We can just call this renderable, right? And this is Karga graphics renderable ID. Oh, come on. Karga graphics renderable. I still haven't got used to the Vim. I was using a Cocoon before, and before Cocoon I was using Vim, but they're not really interchangeable. I haven't gotten used to Vim any, so I still do things in the Cocoon way sometimes. And so that's the renderable. Okay, hold on. What the? I changed something, by the way. Is everything fine? I just changed something and I don't know what I changed. Okay, I think you can still hear my voice, so that's fine. So this is going to be renderable, and they are going to be null, right? So, and if self dot renderable shape r dot destroy, right? By the way, the thing has to be something like this. Let's put this in here, and this is texture. Okay, let's just copy paste this and put it in here. There you go. And we need to create a renderable. So the configuration, right? We need to be able to create the configuration. I'm gonna just save it in there directly here. I think that's what it needs to be done. And we don't have batches, by the way. Wait, what? Right, we don't have a batch shape, batch texture. Right, this is the triangle config. Batch shape. Shape. So this is also something like this. Batch shape. I know that this struct is kind of huge. I realize that. But I think that's what you have to do in these kind of cases. So let's do something like that, and dynamics shape. Oh, okay, we need to do something like this in there. That's fine. I was complaining about this whole time, and I didn't look at it. Okay. Create vertex fragment. Has no member. Oh yeah, it's just create. Okay. It found void. It should be vertex fragment, and okay. So this thing is also if self dot this thing is also needs to be like this. And save texture. Okay. Copy this thing now in here. Okay. What else do we have? Expected optional type. Right. Right. I kind of dumb. Okay. I forgot how this thing worked entirely. So this thing works. Like this, right? If self dot fragment shader, FG, and this is FG. There you go. And okay, are we there yet? 78. What is it complaining about? Oh my god. Uh, okay, I can't put that in there because they are unreachable at that point. Okay, now we are here. Okay, we are there now. So now I'm gonna go just copy and paste this, by the way, here. Okay. So this is sample material shape. So for now, this whole thing is going to be static material and static surface, because at least in this video, implementing dynamic material and surfaces is hard. And in this video, it's not going to be, it's going to be too long. It's already too long. So it is already too long, so I can't do it in this video. What is this called? Ah, yes. Okay, now we get the order. Report. Draw. In both cases, it is empty. So why the fuck are you? Okay. We are using the surface ID now. And this is also order. We're going to be using that. And batch shape. Okay, so this is a triangle config, by the way. And let's just copy paste this in. We can do that later. The triangles in here are going to be empty. And let's put this in here. So this is going to be texture. And this is texture as well. And what else do we need to change? We don't have to change anything else. And that is that. So batch shape. So the line configuration, line config, is going to be something like this. So order lines. Yeah, I'm not going to have that. Okay. So I'm not going to have a different ordering for the lines at this point. I'm not sure if that's actually necessary. I'm not sure. I still haven't decided on that one yet. So okay, so this is going to be draw mode is fill, draw shape is lines. So draw mode is the polygon draw mode. So it can be a point, it can be a line, or it can be a fill. So it may also called sometimes primitive topology or something like that in Vulkan, and not every hardware supports this, by the way. So you need to check that with the implementation, but it's not really that useful. Generally speaking, you can just use it you can just simulate the same thing in software. Anyway, so that's the line config, and the line is empty as well, right? Okay, so these things has to be unwrapped. I'm unwrapping because I already created it. If it wasn't created, it would have been. Oh, it's a union. Oh, that's why I did like this. Because the mode is union. Wait, what? Has no member empty. Draw. Oh. Oh. Ah, I see. I see. I forgot. The drawable in the Karga graphics interface is also can be static, which means you cannot update this after you created the first thing. Then there's updatable, which means you do update, but sometimes, not every frame. So it can retain its own drawing state inside of the implementation. And the immediate is literally every frame. The drawing happens and it always resets every frame. It's immediate mode rendering like OpenGL, for example. That's the difference. The updatable is more like the old GUI libraries, like the Qt things. The static basically means, okay, you draw this once and you never update it again. That kind of thing. And it's kind of a weird distinction to make, at least with static and updatable. But it does matter. It does matter, and you can optimize for it. And Karga is not really for user experience. It's for more. You don't really need to use Karga in your application code. You are using Karga for creating things like this, what I'm doing right now, a module. So it's easier to use. It's more in line of your application, what your application needs. It's more in line of that. That's why you use Karga. You make an abstraction on top of Karga and use it in your application. That's the idea. And I think it works pretty well. Anyway, so this is missing E, by the way. So what is the, okay, it's compiling. It is compiling. So we did create everything we need at this point. Now we need to be able to create the batch renderer. The batch renderer. I have this thing called getVir, and that's basically the batch rendering part of it, and it's very much dependent on the implementation. As you can see, it has a lot of things like this. So this is the drawer, maximum submit count. Let's put this in here as well. And so how can we do this? It's doing self and batch here. Okay, so I'm gonna open renderer here. I wanna see the, okay, so we have batch shape, right? I'm gonna do, by the way, I'm gonna make this something like this because otherwise it's going to be too much. This is shape, drawer. This is shape only, drawer. So that's important distinction because I can't really separate the shape and texture into one. I have to separate them, otherwise putting them into one generic function is going to be too much. It's too much complexity. And this is batch shape. I don't have to do batch shape. And the mode is trying, okay, dot modes, okay, something like that. And this is the renderable. And this is creating a renderable configuration. So this is in batch shape dot, and I think this is supposed to be something like this, mode, and then renderable config. Right. Let's see. Renderable batch shape mode, but this is just triangle. This is triangles. So we're going to put S in here, in there, apparently, so it's easier. And that's it. S. So we need to do lines, triangles, triangles. Okay, there we go. So that's the get shape there. And what this does is basically if it has reached the limits of the batch, it creates a new one and returns it. So otherwise it gets the last batch, the empty batch, and gives a pointer to you, so you can use it. It's simple, yeah. Shape renderer. You will see what I mean by now. For example, you do draw rectangle, right? Let's put this in here. So you do draw rectangle, right? Close this. So this is drawer shape up here. Get shape, right? So you do get shapewear. It gives you a batch. It gives you the batch pointer basically. So then you put the vertices into that batch, and the batch is generic enough that in the rover it is easy to create. So this is the entire batching thing. Again, it's the abbreviation for vertex index renderable. It creates a renderable, and it also creates a drawer for you. And drawer is what literally you use for the drawing vertices in CUDs generally. You can use your own thing if you want to, but this thing also works. I already put everything in there what you need, so it's not that thing. A batch GPA. By the way, this is called batch GPA. I call batch allocator. Let's call this batch GPA. I think that makes more sense. Yeah. Okay. There you go. So that's that. The problem I think now is I'm not quite sure. Wait, I think I did something bizarre in here. Did I? Oh, I didn't. Okay. I did. Renderable. Yeah, I don't create this, by the way. Because batch does it for me. Right? Yeah. That's the thing I was kind of what the fuck I was doing in there. Okay. Now you do need to destroy the batches though. So you go through it like this. And I'm gonna just put this into this function here. Public not public. This is just destroy. It's going to take itself batch shape. It is void. It takes a renderable. It takes a renderer interface. Carga graphics interface. There you go. And we put this in here. Something like this. It also has to have a GPA apparently. And oopsies. There you go. That does the destroy. So you do self.batch shape batch, I think batch.destroy, right? This is nullable, right? Yeah, it is nullable. Okay, so this is going to be a pointer. So this is going to be a texture. Same thing for the texture as well. That's important. And we don't need to destroy here though, because we don't create anything in create. And we do kind of the similar thing in here. This is batch texture. And we just remove this from there, and that's that. Okay, so it does compile. Great. Let's call draw rectangle and see what it's gonna do. Is it going to shit itself? We'll see. And new render examples. Okay. So draw calls in here. Okay. Broski. Okay. Come on. All right. Render draw rectangle, right? And catch error. I'm gonna log panic. Fail to draw rectangle. This is renderer. Fail to draw rectangle. Error. Now, before that though, we also have another error here. Do I want to make the dynamics dynamic? Like, do I? Okay, this guy wants to draw a rectangle, but he didn't give me a dynamic where I create a rectangle. So, should I just create one for it? I think that's a good user experience. It is implicit behavior, but I think that's a good user experience. So I need to create a rectangle. I need to create a whole. I need to create the whole batch system. So I need to create the whole fragment shape, the material shape as in here. It's kind of bad, because you had one error, which was renderable create error, because the batch creation depends on the renderable creation. But now you have two other different error sets where you create a material and you create shaders. Right. Uh but I think for user experience sake it is fine, even though it does create some problems where you don't know, okay, is this gonna create a renderable shape, or is it going to create a shader? Is it going to create a material? What is it going to create? I don't know. It might be any of this or all of these. Is it going to be slow? We don't know. But it is just a one-time cost. So might as well just put it in there, right? Like, might as well. I mean, it doesn't matter that much. I'm gonna put the error set in there, by the way. And this one here as well. This is going to be updates error. Not update error. Hold on. What the fuck? Okay, zero error. this thing is going to return a draw error. So this is where we create that thing. Now the shader Sphere thing, we kind of have to now make this into fields. Window, I don't like this kind of this thing is so ridiculous. This field, this argument is ridiculous. I don't like it, but I have to use it. I don't like it. I will change it later on, but oof, like oof. It disgusts me. Okay, I'm gonna create a public function where I say, okay, create shape renderer if need to be. This is maybe maybe create shape renderer. It's going to take itself. And the renderer, right? Yeah, it's going to take renderer. Karga graphics interface, and it is going to return an error. This is create error, by the way. So I'm gonna just pull this entire thing in there. And this is self. Oh, it also needs a surface ID. Ah, I need to store that. That's fine, actually. That's fine. Surface ID is an ID, so it should be fine. So this is the cost of implicit behavior, by the way. You're seeing in real time. You have to have way more information to do things in an implicit way. But it also makes the user experience very seamless. Sometimes, in this case, it is going to be very seamless. Because otherwise, you would have to say, okay, update the dynamic first. Okay, that's going to create a variable. So I have to pass that function in the surface ID, the shader, Sphere5, renderer, and allocator, all of those things maybe. But now I can just, okay, draw rectangle and don't have to worry about it. Yeah, right. Although I think you still have to worry about some of the things. The order. Oh yeah, okay, it's in there. In this case, you don't define the order, by the way. You're not allowed to define the order. um, so and this is going to be order. Karga graphics renderable config order. So this is that. This is maybe though. So this order is going to be don't care at this point, actually. So put it in wherever. That's what it means. If this is false, by the way, that's what it's gonna do. If it is no, then do that. Okay. And that's going to create that, right? So we can put this thing in there. I thought maybe it should. It makes it actually kind of easy. Now we do the same thing. Maybe create a texture render this time. And now we're just gonna copy and paste this thing in there. It kind of simplifies it, and it also doesn't simplify it. It's kind of different trade-offs, I guess. Different trade-offs, right? Try self dot maybe create texture. So now this Erdofer, by the way, has to be here. We need to put an Erdofer here. This is the shape one. And now we don't need to put the Erdofer in there, by the way. No, we still have to put it in there. Fuck. Okay. This is Erdofer. And there we go. Right. If this fails, it's going to clean up after itself anyway. Yeah, we don't have to. We need to do it for this thing. Yeah. Okay. It is going to be null. After destroying, these things are not nodes, right? Yeah, it is not nodes. Okay, so I have to do a null here. So I don't have to worry about them being double destroying things. And that should be fine. That should be fine. The material itself, it doesn't. Yeah, that's fine as well. Yeah, okay, that is fine as well. So now this can stay here as is. It can stay there as is. And we're going to put maybe create shape renderer here and put try here. Right. Is it compiling? It doesn't, it requires a renderer, that's why. Expected one argument found 0. Oh, because I didn't put the arguments in here, right, okay. Oh, it doesn't have that, okay, that's fine. So don't care is going to be dynamic, by the way. Because so you can change it later on. Right. Okay, so we are in here. Finally, we got that working. Draw rectangle. So it's going to take the renderer first, then the position. I'm just going to make it 0, 0. The size is going to be 30 by 30, and the color is going to be red. Right. Make this like that. And there is also one more thing. By the way, this is not compiling. There is no field name batch shape dot triangles in structuring or batch shape dot triangles. Because it is nullable. Because it is nullable. Ah. Ah. Ah, I see. Ah. I think, yeah, okay, so the error was, so I think Zig cannot go it into, like, it cannot do, okay, it does have self.batch shape, right? But it doesn't go into more deeper than just one level. So it doesn't go, okay, self.batch shape dot triangle. It doesn't go into that deep. It goes only one deep, one dot level deep. That was the error, I think. So it's no field name batch shape dot triangles renderable config. Right. Because this thing has to have, and it's going to give me the same error. Look, as you can see, it doesn't go too deep into it. It goes only one deep, one level. So this is self.batch shape. I didn't know that actually. That's something I learned now. Triangles renderable config. So it's not renderable config, it's just config. Right, it does compile. Okay, so we need to present these rectangles into the renderer. So we need to update the renderable state in there. So to do that, we have a very simple way of doing this. I'm just going to copy and paste this and renderer. What we need to do is basically, okay, update the drawable in the renderables, because we put new stuff in the drawable in the renderables, so we need to update it before presenting the renderable state into the screen, into the surface or whatever. So this is for the shape. Okay, I can make this compile time generic, but I can also hand do this by hand. This is dynamics mode, by the way. Maybe it makes sense to make this generic because it's already repetitive enough, but it's also not. So I mean, is it worth it? Like, is it really worth it? This is actually going to be actually. I don't think it's worth it, yeah. Yeah, I think this is fine. Okay, we can put that in there like that. There we go. So we need to do kind of similar thing in there. And batch.triangles, batch.lines, this is gone. This is like this, and this is removed. This batch is going to be dots. This is removed. This is going to be dots. And this kind of thing. And then we get this in there. Well, we just do this kind of stuff. This is batch texture. And yeah, something like this. Right. It's duplication still, but like, do I need to make this generic? I don't think so. I mean, I made this generic because I didn't want to duplicate it. I would have to have the same thing in two, so it needs to be something like this. Otherwise, that's why I did that. So maybe I should do this in here as well, right? Oh, I can put this thing in the. I can put this in. I can do something like this, by the way. So that should be a bit more toleratable, I guess. X interface. And this is going to return renderable update error. Karga graphics. Something like this. I think this is tolerable. I don't know what you think of it though. It's, I guess it's fine, right? So this can return that, and we just do. So it's a bit cleaner. We're gonna do the same thing in the reset part of this as well. So this is just this. And this is going to be, well, for reset, I guess. I guess it's fine. For reset, we don't have to do it. It's simple enough. It's small enough that we don't need to do it. So new, in the example, we need to do render update here. And this is going to render patch error. We're gonna panic again. Render failed to update error. And there we go. Font const. This one. 216. These are const. Okay. It did compile. Okay. Run it. Let's see if we can. Okay. Moment of truth. Red rectangle. We are expecting a red rectangle. At 0, 0, 30 by 30. Rectangle. Come on. Oh, shit. Okay. Switch on corrupt value. That's the first time I actually experienced this. And I know why. Like I told you, that it would come to bite my ass later on. And it did. Because I put undefined somewhere here. Okay. I put undefined here. Hmm. Hmm. I can't just put empty there. Can I? Though. Can I do this? I'm not sure. It seems like it won't work. Hmm. And yeah, it's incompatible because right. This is the thing that I hate with compile time in Zig. You cannot do this kind of stuff. You cannot do it like this. You have to put something in here. But I can't put anything in there because it's going to be invalid attribute or invalid the layout. So I and I don't know honestly what to put in there. I can't put anything because hmm. Okay, I'm going to make something so fucking silly. Uh that I don't even know if it's gonna work. Can I do, by the way? Uh okay, okay, maybe this will work. Wait. Maybe this will work. Right. I think it didn't work though before. Right, if I remember that correctly. Okay, that's the thing. I don't think this worked. Uh, uh, huh. Union initializer must initialize one field. Can I put in void? I cannot put void in there. Because it's expecting this thing. It's expecting this thing. And I cannot put undefined either. And I cannot put an attribute where there is none either. So is this the end of generics here? um, do I really have to do whole switch function for this? Okay. Okay, I guess we're doing it like that then. Like, I didn't want to do it this way though. Because it's kind of ridiculous. The else part. And which one is this? Okay. Hmm. I guess I can just put this attribute in here as well. So I cannot do this either. What the fuck? Okay. I can at least do this kind of stuff, right? Yeah. And layouts. Where is the layout? Okay, it's in here. There you go. Did it compile? It did compile. Uh, new render. Okay. Okay, it does something. Okay, holy shit. Hmm. Oh boy. Oh boy. Holy shit, what the fuck happened? Memory leak. Okay, I get that, but mm, well, the reason it didn't show anything, by the way, was because MVP. I didn't have any MVP in there. I didn't put the uniform buffer in there. So that's one of the reasons, by the way. But the other part is kind of interesting, where it created shit ton of stuff, shit ton of batches and renderables. That's the bizarre part. That's bizarre. I did say this is immediate, so that is bizarre. That is bizarre. Alright, so is it a miscompilation? I doubt it. I doubt it. I think I missed something. There's no way this is a miscompilation. Um, yeah. Oh boy. So let's see if the problem is draw rectangle. Yeah, it is. Okay. The problem is draw rectangle. Let's go in there. And the problem may be the reset part of this, by the way. Maybe create. We do set the dynamic shape. Dynamics shape, right? Right. We do set that in there. Batch shape is null. Batch shape is null. Batch shape is null. And it shouldn't be. Ah! Ooh. I see. If this is null, do this, then do this. Ah, but the problem is, yeah, 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 yeah. I see what's going on. Oh, it's creating this thing again. It's creating this thing again. So, um, force create force. Ooh, there you go. These are force creations, right? And this is not a force creation in here. So it was creating, it was getting there too much, I think. That's the problem. And there's a problem, okay. So can I not? Oh, come on, Zig, come on. You can't just infer this like this. You can't just do that. Like, this is such a simple thing to do. It would be nice to have that kind of quality thing, but by the way, the force is true in this case. So this is going to be return. And okay, at least I can chain ifs like this because they are also an expression in Zig, so you can chain expressions like that. At least you can do that kind of stuff. So expected one argument found two. Maybe create texture renderer. This is maybe create shape renderer. Oh, I have to do this thing in the. Aha. So this thing can be maybe generous, a bit more generic, but so I'm gonna do one recursive thing in there, so and this is semicolon. There you go. That should do it. Okay. Well, at least it's not. Oh, so there's still a memory leak. It's probably because I didn't deinitialize the thing in the new renderer. Right? Yeah, I didn't. Renderer destroy. Right, I didn't do that in there. Okay. So that also has a problem. Batch destroy. That thing has a renderer here. There you go. And it apparently expects two things. Batch GPA as well. Okay. Okay. The Vulkan gave me an error. The validation thing gave me an error because oh, there's also still a memory leak, by the way. Okay. Because Nibo is being used and robot has never updated. Yeah, as you can see, Vulkan validation layer is really very nice. It literally teaches you how to use Vulkan, by the way. If you're learning Vulkan, you have to use the Vulkan validation layer. You have to enable it. Um, anyway, so this still has a um, it still has a leak. So it's been allocated in the 241. How did I deallocate these things, by the way? Oh, I deallocate the... yeah, I see. I deallocate this thing as well. Which makes sense, actually. Makes sense. And... okay. Oops, what the fuck? Okay. Okay, there we go. Okay, there's no... there's no... what do you call it? There is no leaks. Okay. So now let's try to update the MVP. Updates material. Alright. I'm not gonna call update material because I don't think that makes sense to call it like that. It's kind of a bizarre why I called update material. I think it should just called update MVP. Because that's literally what we are doing. Material, shape. And we do this thing again for the texture. And that's that. And now we need to update the MVP after we created this thing. And there, updates MVP. It's going to require the renderable, the renderer interface, and the MVP. MVP is this. It's going to be, we need to pointer cast this, something like this, and align cast as well. So it's aligned, and so it doesn't worry about it. And this can be return an error, so we're going to log panic. Failed to update render MVP error is this one. I'm doing this as a panic and log panic, and log panic is literally basically log that error and the panic. I'm doing it this way because you can't recover from this error, by the way. Maybe you can recover, but you try to use the old one, but at least in this kind of application, you can't really recover. If you want to be able to recover from this, you have to do things a bit differently. You have to have backup renders, backup MVPs or backup descriptors like that. And currently we don't have any of that shit. So red rectangle. There you go. Red rectangle. And let's try to add request as well. I'm gonna make it true. And it's going to be one draw call. One draw call. Instead of each frame, there's going to be one draw call and it's still going to draw it. Let's see. As you can see. And we are calling the updates for each frame because it does check for the request. If you requested, okay, update it. If you didn't request it, don't update it. And the drawables are created for that kind of purpose, so we don't have to worry about the implementation destroying our updatable drawables. And it's been 3 hours, I think. It's been 3 hours. Oh my god. Holy shit. Right. I'm gonna do the texture. And I'm gonna do the texture and then call it the day. I don't have a texture to draw, by the way, so that's a problem. That's a problem, actually. Oh, I don't want to do a separate. I don't have a PAM. Ah, wait, I actually wrote a plugin for a separate, right? I can use it. Okay. Okay, I'm gonna copy this. Draw rectangle. Draw rectangle. Let's call it texture rectangle. Yeah, I think that's fine. Get texture where? And this is going to be a texture there. Let's implement that. So I don't think this thing has a mode. Yeah, this thing doesn't have a mode. Maybe create texture renderer. And this is texture. By the way, let's just get that. It's implemented way more simpler. Way more simply. So this is just this. This is drawer texture dot vir. All right, so that's that, and this is batch texture, and this is batch texture triangle config. Batch GPA, batch items, batch texture triangle dot items, triangles items. Right, and texture triangles add one, and I think 204. Oh fuck, I'm modifying the wrong thing. Okay. Okay, I was modifying the wrong thing. There you go. Ah, happens to all of us, I guess. Okay, it did compile. So I need a texture now. I think technically I have a texture, by the way. But let's create a new one anyway. Oh my god, broski, what the fuck? Come on. I don't have Steam opened, and I don't want to open it, so I'm gonna just open it from here. A separate, please. Thank you. Thank you, separate, for not depending entire application into stream. Jeez. Okay, let's draw. Okay, and yes, something like this. Yes, this is literally what I want. Export it as PAM. Let's choose the file path and put examples. Sad face. Export it. Great. Thank you. Thank God I made this plugin. Jeez, that's very useful actually. Very useful. So I'm gonna steal some code from Palmweaver. Let's steal this. Okay. So then new renderer. I'm gonna put this in here. And okay, this is setface.pam, and this is not grayscale, this is RGBA 8, and this is our nearest, by the way, not linear, otherwise it's gonna be blurry. And this is not grayscale, this is RGBA 8, I think. Yeah, it is like that. Okay, so now I want to, okay, now we need to be able to put the image in there. basically. Render zig. I may have to. It's fine, guys. Renderable update image. Okay. Update image browse. Okay. Put image in there. Image. So here's the thing. Should we return from this if we don't have a texture renderer, or should we create one? Huh. I guess we're going to create one. I guess we're going to create one. Oh, we also have another thing in there. We have a texture size in there. I don't know why we have that, by the way. I don't know why we have that. So did I use that in anywhere? Like, I think I had a. Oh, I am using it. Okay. Texture size. Okay. So material texture. I guess it's going to be in here. Batch texture. Textures. It's going to be size. Well, texture size. It's two floats apparently, so two F32s, right? Right. Two F32s. And where are we? Okay, here. This is batch texture and this kind of thing, texture size. And we're going to say, oh, this can return now. Hmm. Hmm. Okay, for now, let's not create that. It's a bit too much, actually. It's a bit too much. Window. Is it a bit too much? Ah, okay. Okay, I am going to do it. Man, this is too much, though, I think. Implicit, I kind of don't like it anymore. I kind of don't like the implicit behavior anymore. Okay, 171. Texture splatness with 0. And it's going to have another error, by the way, because I didn't say the batch and batch. It's not just batch, actually. Oh my god. Okay, can I just do batch batch texture? Yeah, I think I can do that. It did compile. Neil. Okay, Neil, come on. Neil. Neil. And we are going to be updating the image. This is called image, texture image. Image info, image. This is image. Info. And this is the image itself. Okay. Image. And okay, hold on. Okay, I had to free some storage. Okay, so we do have the texture position here, which is going to be 0, 0, and the texture size. So the texture size, I guess we can do image dot width, image dot height, image size 0, I think, size 1. I don't, yeah, it is just an array. So it has an error. Get optional type doesn't support field access. Okay, so there are some errors. Render will create error because this is draw error. And 253. The batch texture. Okay, this thing has to have this kind of stuff. And this as well. Okay. And 325. This thing is also. This is also. And this is returning draw texture. Where? Okay, so it does compile now, I think. Yeah, it does. Okay. Let's open. And it's sec. Oh, it's a buffer overflow. Oh, whoa, 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 whoa. Why did it overflow? Mm. Where did it overflow exactly? It's in 76. 76 in here. What is overflowing? Maybe create texture renderer. Did I do something fucky wucky here? Did I do a fucky wucky? There is no mention of shape, right? There shouldn't be any shape. Draw shape. Only draw shape. That's fine. Buffer overflow. Buffer overflow. What the fuck? Okay, what the fuck is going on? What the fuck happened? Is it time to open up RAD debugger, broski? It is time to open up a RAD debugger, I think. Let's see, broski. Okay, run. What is the call stack? Okay. Create. So what did overflow exactly? Uh, this thing hits a trap. Hits a trap. Okay. Mm. Oh, hold on. I put the wrong thing. Step over. So that did execute. Hmm. I'm not sure. I should. What the fuck happened? Wait. What happened? Is it this thing? Illegal instruction. Okay, wait, it's not illegal. Okay, so it has to be this thing, right? Am I tripping? What the fuck? Okay. What the fuck happened? He wasn't doing that before. Okay. Uh, so, so is it this thing? Oh, wait a minute. Wait a minute. This is not actually a force. Ah, fuck. Okay, we are removing the force thing here. I'm not sure if this is the error, but I think I just realized I shouldn't do this like this. Um, I should do. This is just create. Okay, I'm gonna have this in. Okay, hold on. This is just create. So we don't have this. If this is null, just return. Right. If that's null, just return. Or don't even worry about it actually. And do that. And otherwise, dot. This is create. Come on, bro. Lower it. Okay. And this doesn't have that in there. Okay. Mm, right. Just return. No, we don't even care. Right. And this is the texture one. This is the shape one. And create shape render. There we go. And these things are not in there. Let's go in here. That's texture. Okay, that's fine. So now these are not maybe, they are just create, and they don't have this kind of stuff in there. And these are not gonna create if it is false anyway, so it's fine. If it doesn't have anything, it's not gonna create. But that's fine. Okay. So I don't know why it's buffer overflow though. It's still buffer overflow. Okay. Buffer overflow. It's in here. It's kind of a bizarre thing actually. What the fuck happened? What the fuck happened? Right? What the fuck? I didn't miss anything, so hmm. I didn't update the viewport. That's a thing as well. I didn't update the viewport. Uh, Batch. So okay, that's a problem first of all, but the second problem is worse actually. I don't think it's something related to the viewports. Updates viewports. And this is gonna take south.dynamics.viewports. Right? It doesn't return an error. It does return an error. Renderable update error. Renderable update error. It does take a render. Oh my god. Okay, what the fuck? Renderer. Oh, well, we shouldn't need to. Yeah, we shouldn't need to actually. Yeah, we shouldn't need to. Okay. And it's still buffer overflow or detected. Can you just tell me what's buffer overflow, bro? What is the buffer overflow? Which one is it? Like, what is overflowing here? I don't have any buffers created at this point. It's empty. And it wasn't... Oh, was it a miscompilation? Holy shit, wait. I think it was a miscompilation. Okay, there you go. So the UBO was not updated, so that's the MVP. So we need to do kind of a... Okay, yeah, we need to do this kind of stuff. And why did it give me that error, by the way? Even though I did update the UBO, didn't I, broski? Broski. Oh well. Hmm. Not quite sure. No. Not quite sure. Not quite sure what happened there, but okay, I think fuck. Invalid descriptor. I see. I think I know why. Maybe I know why. Create texture on the invalid descriptor. Oh. Wait. Texture, right? It is texture. Invalid descriptor. Oh, whoa. I don't have the texture in there. Wait a minute. Ah, there we go. The fragment shader. Right, okay. So this is basically if stdmem.equal u8 name texture, right? In the else case, it is going to be nothing. So we need to copy this. Okay, something like this. I think. Yeah, that should be. Okay, we forgot to put the thing in the fragment shader, I guess. But that's fine. That's fine, broski. That's fine. Okay, so now we have another error. In EBO has never used. Okay, that's fine. I know the problem in there. I'm gonna, by the way, just make sure to put this as a shape only, because in the else case it's a compiler error. It's an unreachable thing. Just to make sure I would do that, I need to do that just to catch myself if I do something wrong. So this update image has to be before the MVP, I think, because otherwise it's not gonna update the image. So that's the implicit behavior problem. This should work though. Oh, there we go, sad face. Okay, we have still errors, but hold on. I'm gonna put this thing in the like 100s by 100s range, and I'm gonna make this white. So what's the error, by the way? In EBO, it's still complaining about the EBO. Still complaining about it. Ah. Ooh, what the fuck? UBO is being used in Draw but has never been updated. Oh. Another implicit behavior problem is there is no reason for this MVP to update the rectangle shape drawing because there is none. So we do shape dynamic, or we can do static at this point because like I want this to be in fonts. There you go. Voila. Hell yeah, broski. Okay. So, and it does return successfully. Okay. So this is a dramatic improvement over creating two entirely different things. Although it took us about 3 hours, I think. But it is 550 lines of code. And if you take a look at shape render itself is 300. And the texture render is about the same, 200. So it's 500, but in one, without too much code duplication, I think. Too much at least. There's still some duplication. I think it is what it is, but and I think I reached what I needed to. I'm not sure. I'm still not sure about this implicit behavior. Not sure about it. And yeah, not sure. So I think for the sake of clarity, otherwise implicitly, if any shape rendering calls any drawing function are called, it is going to be implicitly created and the order will be don't care. Something like this. And I'm gonna put this in here, no texture. And I'm gonna make this implicit. I'm not gonna make it like this. I'm gonna make it, I will make sure you put that in there. So this is the image and this is the front. There you go. I will make sure to have that like that. I still don't like default values actually. The more I use, the more I don't like it. The more I use default values, the more I don't like it. Yeah, there you go. And it should work in immediate mode as well. Immediate. We're going to put them in here. Okay. There you go, it does work. Okay, great. I'm not gonna implement every single function in shape rendering because it's been so long. It's been it's about too long. It's too long already. But I guess this is going to be it. Thank you for anyone watching for this long, by the way. It took too long than I expected. I thought it would at most take 2 hours, but it took about 3 hours or maybe 4. I'm not sure. We'll see. But it does work. And I think I'm happy with it because let's be honest, this is way more preferable to than having to create two different types and using them. I think I can show you an example, I think. So, okay, as you can see, there is a background renderer, which is a shape renderer. That's and another one, it's a texture renderer. And you destroy them separately, you create them separately. It's a code duplication, by the way. These things could have been front as well. I could just add this functionality into the new renderer either. So, okay, the shape rendering, the order is different, the texture order is different. They're already in there, so you can do that as well. So you don't have to do different things in here. The mode can be different per shape or texture as well. We can add that in there, but I didn't add it, but we can add it. So you have to create them twice with same configuration basically. You have to update the material and viewport twice, the same thing. You have to call update twice, the same thing. It is too much. It is too much. And now you can just say, okay, draw rectangle, draw texture rectangle, update the image, update the MVP, and there you go. Way more less, way less. And I like it. Okay. Right. This is going to be it. The Git code work repo is here. Thank you for everyone watching again. And I will see you on the next one. Bye bye.